Hello and welcome to the special lecture series for the LVCOM organized by GTU and in collaboration with the Cognifront. My name is Arpan Pandit and in this lecture we will see projections of line. In the past lectures we have seen the 5 types of various projections of line. How we can have the problem. There are basically 5 types of problem we can have in any sort of projections of line. In this lecture we will see the special animation made by the Cognifront software to utilize how we can visualize the projections of point as well as projections of line. Apart from this, we will see some of the problem which can be asked in the exam for the projections of line. Now let's start with the nomenclature of projections of line. Let's have a look at the first slide, please. If we see, we have considered vertical plane and horizontal plane straightened. We have straightened the horizontal and vertical plane. Now over here, as you can see, the horizontal plane component, which means the top view component, will denoted by A dash B dash. Over here, the top view component will denote by simple A and simple B. If we look, XY line is located exactly in middle of the vertical plane and the horizontal plane. Where these both two planes are intersected, we have got a XY line. Now, if we see that this is the orthographic projection of any projections of line, we need to have front view and top view, and we need to check the inclination with the horizontal plane and the vertical plane. Now as I told you earlier that we are seeing the nomenclature, how we can nomenclate any sort of projections of line. If we see, the angle with vertical plane is denoted by alpha. Over here, angle with horizontal plane is denoted by beta. Apart from this, if you see that here top view is not parallel to XY line. Top view is not parallel to XY line, but it is not showing true length and true inclination with the horizontal plane. If you see that the top view is not inclined to the XY line, which means that we cannot have the true length of this AB line. If we don't have the true length of AB, then we need to find out. How we can find out the true length of AB, we will see in the further part. Apart from the true length, we cannot have the true inclination. True inclination means that the angle with the horizontal plane. If we have any sort of angle with the horizontal plane, then we must describe it. But with this top view, we cannot have the proper angle, which is not right. So what to do? When front view and top view is shown, how we can find true length? What we need to do, we just rotate the views to determine true length as well as inclination with the horizontal and vertical plane. Over here we seen that the top view is not parallel to XY line. Because of that, true length and true inclination is not achieved. In this part, we will see if this is the case, how we can find out the true length as well as the true inclination with horizontal plane as well as vertical plane. As you see, the same thing done over here is repeated. The front view denotes as A dash B dash. The top view denotes as AB. The top view is lying on the horizontal plane and the front view is lying on the vertical plane. Now if you see, we need to find out the true length, which is actual length of any line. This is not the actual and correct length of line. What we are seeing is a imaginary line. What we are seeing a angle is a imaginary angle. We need to find out the actual angle and actual length. It's called as true length as well as true inclination with the horizontal plane or vertical plane. Now what we are going to do to solve this kind of problem? We will just rotate our top view. We'll just rotate our top view like this. How I can rotate? I will put my compass on point number A. I will just put my compass on point number A. Take radius as AB. Put compass pointer on point number A. Take radius as AB and mark a arc. Arc till what point? Arc till a line drawn parallel to XY line which is passing through point number A. In the past lectures I have told you that when you are doing any sort of projections of line method, you need to draw 4 parallel line which is parallel to the XY line. One passing from the B dash, one passing from the A dash, one passing from the A and another from passing from B. We need to draw 4 parallel line which is parallel to XY line. 1, 2, 3 and 4. Now what I have done to rotate top view, put compass marker on point number A, have radius as AB and just marked a arc like this. Now how we can do proceed further? We have just mentioned a arc like this. We call this point as point number B1. We will call this point number as point B1. What is the use of this point number B1? We will extend this point number B1 perpendicularly till it intersect with this B dash parallel line. I am repeating once again. From point number B1, what I will do? I will draw a perpendicular line which is intersecting to the B dash parallel line. Is it clear? Now what next to be done? Mark it as B1 dash. If this is B1, then mark it with B1 dash. Always remember, top view component will be simple one like small a, small b, 1, 2, 3. Front view component will be like with the dash, a dash, b dash, c dash or 1 dash, 2 dash, 3 dash. Accordingly, in the top view we have given name as B1. Over here we gave name B1 dash. You can give any name accordingly as per your convenience. I am just giving you an example how we can find out true length and inclination with horizontal and vertical plane if front view and top view has been given. Now what next we can do? Till here we have done, put marker on point number A, take radius as AB, drawn an arc till passing through A parallel line, extend that parallel line to B1 dash perpendicularly. Now what next to be done? Join A dash and B1 dash. Join A dash and B1 dash. What is it? It is the true length of any given line. How we have achieved this? In the previous over here we have written that we just need to rotate our views. I have rotated this view. If you rotate any view, then you can have your actual length. Mark A dash, B1 dash, take measurement of it and write true length is equal to so and so in the given area, and this is your given true length. This true length we need to find out. We have achieved finding this true length. Now what we need to find? We need to find out the inclination with the horizontal plane as well as vertical plane. Now I have got inclination with the vertical plane marked with an angle called alpha, marked with the angle called alpha. Use your protractor and measure the angle, and you will get the desired true inclination with the vertical plane. How we can find out the true inclination with the horizontal plane? Like this. In this sketch, the top view is rotated and made parallel to XY line. Hence, A dash B1 dash shows the true length and true inclination with the horizontal plane. Is it clear? To get the top view rotated, you will get the true inclination and true length on the front view side. Now what if we want to find the true inclination with the vertical plane? That we will see over here. Now true length is known. We know what is true length and how to locate the front view and the top view. Now we have got component A dash B dash, true length is drawn, which is further rotated to determine the front view. Now we have got this view over here like this. Now we will proceed further with this itself to get the remaining one. As you can see over here, we have got vertical plane as well as horizontal plane. Where both these plane get intersect, we have got the line XY. Now over here, A and A dash is given, A and A dash here is given. This A dash B1 dash, A dash B1 dash, this true inclination has been given. According to that, true inclination is marked over here and drawn a line like this. It is our true length. With respect to that, we can get the true length on the another side as well. We have just extended that line, we have just extended this line till passing through point number B, and we have got the true length over here and the true inclination with the vertical plane. Now we need to find out our front view and top view. How we can find out? Again see, I am drawing 4 parallel lines passing through B1 dash, A dash, A and simple B2. 4 parallel line with the XY line. Always remember in the projections of line. If you forgot to draw 4 parallel lines, then your problem might be wrong. Now we need to find front view and the top view. What I will do, mark AB2 as radius and draw a perpendicular line till it reaches to the A parallel line to XY line. Extend it further till A dash line. We can get our B2 dash. If we extend this line, perpendicular line to A dash line, we can get point number B2 dash. Take A dash to B2 dash as radius, A dash B2 dash as radius. Your pointer would be on the A dash. Draw a arc till it cut B1 dash parallel line. I am repeating. Take a marker, take a point on A dash, open up your compass and set the radius as A dash B2 dash. Draw a arc till it cuts the B1 dash line. mark it as point number B dash. Join A dash and B dash and you have got your front view. Always remember, front view and top view are in line itself. Front view and top view are connected with each other. Because of this, what I have done, I have just draw a perpendicular line from B dash till it reaches to the B2 parallel line. We'll mark this point as point number B, like this. Join this line, it called as top view. If you have got the true length, then this is how you can get your front view and top view. If you don't have your true length and have front view and top view, then you need to rotate one view to achieve your true length. Very simple yet very effective. If you have, I am repeating once again, if you have front view and top view, rotate those view to get your true length. If you don't have your front view and top view but you have true length, what you will do, you will just mark a arc like this and you can get your front view and top view with line in each other. Very simple and very clear. These are the angle with the horizontal plane and vertical plane shown as below. Now, what is the nomenclature for the same? We have drawn so many points and we have got so many numbers written in the projections of line. But what does they mean? What does they represent? If you see this drawing, we have got some reference number given, reference nomenclature given. According to that, you can use the nomenclature or you can create your own. Like, if you see in the picture, A dash B1 dash is a true length.